Okay, so we see our percentages here for problem number 78. We said that this was going to be a three-part or branches of the tree. Okay, I am going to designate W for white, B for black, and H for Hispanic. I know, really deep, huh? And then, well, I'll see what I'm going to have to designate the rest in a minute. Okay, so here I've got white, I've got black, and I've got Hispanic. What percentage of the city is white? 40. What percentage of the city is black? And what percentage of the city is Hispanic? 20. Okay? Now, it adds up to be 80%. Now, as we add these additional branches, now we're talking about the mayor's support or the lack thereof. So right here, we're going to say this is support. So let's make a note that here, this equals support. And then let's also make a note that S not is complement, means we don't support them. So we're not going to support homie. No support. Yeah, go ahead. Yes, it adds up to be 100%, the 40, and the 20. Okay? Now, here, if you're white, what percentage of the people supported this mayor? 30%. And then let me put S not. And let me be consistent with the rest of my branches. Now, if you're black, what percentage supported them? 90, which means, and I should have done this up here, but that means 10% did not. I didn't fill that in, so what should that be? Up there for the okay, 70% of the whites did not. Okay, so 30% of the whites supported them. 70% of the whites did not. Or saying it statistically in another way, as I talk about this branch here, 90% support given that you're black. 10% did not support him given that they were black. And then for the Hispanic, it was 50-50, right? Okay. Now, next what we're going to do is just multiply the things across. And as we multiply them across, I want to make sure we understand our symbols. Here, this is the probability of white times the probability that we supported given that they were white. And that equals the probability of support and white. And this is what I was telling you about, that it was going to be easier to understand with different letters. And I think the scenario is easier. Even though we truly understood the idea of taking one switch away and we have less switches, those numbers were just too big. Okay, right here, the probability of white times the probability of non-support given that they were white. And that's the same as the probability of white and the order right there really truly does not matter. It's commutative, but I'm just starting to screw up when I write my symbols. Okay, so I'm going to correct that, and as I correct that, you guys, I want the math. I'll start you off. Okay, which is of course 0.4 times 0.3, which is nothing but 0.12. Questions as you guys finish it? Okay, guys, go for it. Now, I switched these simply for consistency. Considering we have the W here, that's the only reason I did it, and the W started there. Please remember also as we look at this, and I might be I may be being redundant. But the reason that this was a lot more difficult than the problems that we did yesterday, because yesterday, what did we do? We just multiplied the two things together and called it a day, right? But here, this situation, they are dependent on each other. Because remember, the second outcome is based on what happened the first time. And I don't know how yellow on blue is. Any questions? So, as I wrap this up, all I'm expecting for you guys right now is to be able to do the tree. Tomorrow we'll be doing questions based on the tree. And in about 5, 10, 15 seconds from now, we're going to be doing our QR codes. Bye-bye.